Assalamualaikum warahmatullahi wabarakatuh. Today's the presentation is about investigation on application of fly ash and lime as alternative sustainable construction in block material as Inoblock by me, Puan SINATU SHAPIE, and my others researcher Rahim Ishak from Civil Engineering Department, Politeknik Melaka. As introduction, concrete block is one of several precast concrete products used in construction. In general, the concrete mixture used for blocks has higher percentage of sand and lower percentage of gravel and water than the concrete mixture used for general construction purpose. An action for reducing the environmental impact, pollution caused by cement manufacturing, and also to achieve the strength of building blocks, studies are done to obtain the best percentage of these sustainable building materials, which are fly ash with lime, to be used as part of replacement of those cements. Significance for doing this research as to obtain the optimal mixture content of partial cement replacement with fly ash and limestone powder to achieve building block strength, and then to analyze the parametric analysis of strength and durability characteristic of concrete blocks named Inoblock with that of normal concrete blocks. For literature review, from O. Kayali and Bizu on 2004, high demand of construction industry lead to issues where this cement material constantly reduced by the overtime, and lastly it will be fully utilized. On 2015 by Medavi and Martin, rock mining activities also lead to disturbed ecosystem in the quarry. In construction industry, cement as the main material for concrete production produce large amount of environmental impacts at all stages of the process. Fly ash is a pozzolanic silicon or alumina silicose material that in finely divided form and in the presence of moisture chemically reacts with the calcium hydroxide released by the hydration of Portland cement to form additional calcium silicate hydrate and other cement compounds. Thus, concrete containing fly ash can become denser, stronger, and generally more durable long-term, as these admixtures can enhance and some cases can boost in early strength becomes apparent and increase and late strength occurs, said Thomas on 2010. Thomas also said and discussing that fly ash particles will provide a great workability of the powder portions of the concrete mixture, which results a greater workability and lowering of water requirement for the same concrete consistency. And recently, alkaline activation of fly ash recently being discussed as the use of fly ash as source of silica. So for this research, the materials and methods will be correlated to study the strength characteristic of the Inoblock concrete. Cement used for the research work was ordinary Portland cement. River sand as fine aggregate was used in this study, and Class F fly ash, which obtained from thermal power Jima Energy Venture Powerland at Negeri Sembilan plant, with the clean water when mixing this concrete mixture with water binder ratio of 0.55. Experiments were conducted in laboratory of civil engineering at Politeknik Melaka for compressive strength test and shrinking range. Method of preparation of cube with size of 100 mm. Meanwhile, for the water absorption, the tests have been done in laboratory at UTEM with size sample of 50 mm. These four mixture includes mixtures using OPC without fly ash and 3 other mixture with 20%, 40% and 60% of OPC mess with 25% lime mixture respectively. OPC replaced with fly ash by mass ratio at 20%, 40% and 60% of OPC mass with 25% lime mixture respectively designed as P1, P2 and P3 for diversity densities. A reference mixture control and samples were prepared for each cube according to the fly ash content with cement ratio 0.55. Ratio of cement fine aggregate used in this study were 1/2. Water absorption test has been carried out to investigate the rate of absorption for different percentage of fly ash in concrete mixture. Sample of 50 mm, measuredly soaked for 7, 14 and 28 days. So, for result and discussion, the comparison between strengths, the data representative show for average for 6 samples for each mixture. Laboratory test with more size 100 mm shows that the strength of fly ash mixture reached at least 10 Nm² after 7 days. After 28 days, the strength almost 16 Nm² on 20% of fly ash, same value as the control concrete. The maximum compressive strengths, which are 17 Nm², can be seen in the replacement of OPC 20% of fly ash in 56 days, and these values equal to the control concrete. The increased compressive strength after 56 days may be due to the slow hydration process due to the increased use of fly ash in concrete, where fly ash is a slow reactive pozzolan material causing the hydration process to exceed 28 days. From the values obtained, clearly shows that the replacement of fly ash at 20% with the OPC can reach a value equivalent to the control. Fly ash as substitute material effective in properties, as fly ash has a plasticizer characteristic that can enhance the bonding between those mixture, thus resulting mixture to have high compressive strength. In this research, it is proven that the bond between other materials added with plasticizer character of fly ash affecting the concrete properties. Based on density test as shown in table 3, the optimum density will be at 20% substitution. From the table, it shows that the density with 0% of fly ash with 25% lime shows the lowest density value. Compared with the normal control concrete, the density value of concrete normal were much higher than the other mixture. It shows that with substitution of fly ash, decreasing the density value. As the 20% fly ash is the optimum substitute value for this mixture, the average value with 2029 kg per cubic millimeter considered as the best. Based on figure 2, shows the relationship between density and DH. It shows that density value at 20% replacement are more concentrated compared to other mixture. This table shows the relationship of density of water absorption with matured soak period. The result of water absorption shows the density of control concrete are higher than other samples. The lowest density in this water absorption were the mixture with 0% of fly ash. Meanwhile, the highest value is the mixture with 60% of fly ash. With decreasing 3% of density between 20% mixture compared to control concrete, it proved that in terms of water absorption, the mixture of percentage of fly ash and 25% lime is better than conventional concrete mixture. As the conclusion, fly ash instead of cement content in concrete mix have significant result in meeting the requirement of concrete compression strength, similarly with normal concrete. Based on this study, the replacement of cement with fly ash significantly decreased the compressive strength of concrete. It is proven that fly ash replacement of 20% of weight of cement achieved the optimum value of compressive strength and considered the best ratio of cement replacement in a concrete mix at 56. Researchers believe that with the use of fly ash and lime as substitutes in the block concrete mix has a high potential for further development. For the future, researchers suggest that further study needs to be done in terms of behavior of fly ash lime as concrete block, the aging of fly ash lime, and the creep behavior of fly ash lime concrete as block structure. From observation, researchers can conclude that fly ash combination with 25% of lime have a high potential and can be commercial as concrete mixture admixture in addition for developing new block we namely as Inoblock. Thank you.